So in the last video I was explaining the logic, right? So I was explaining regarding the while loop here, right? While I is less than is equal to j, the partition part here. So while in this one, until the while is actually less than is equal to j, I'm going to, what I'm going to do, I'm going to increment I as well as I'm going to decrement j. What is the condition? The pivot element should be greater than a of I, then only I'm going to increment I. At the same time, while if you want to decrement j, the pivot element should be less than a of j. Okay. So if in this case, if I is less than j, what I'm going to do, I'm going to exchange a of I with a of j. So I will explain this part, this partition part, how exactly it works. Once if this condition crosses, if while I is less than is equal to j crosses, I mean if I is greater than j crosses, what will happen? I am exit from the group. Again I'm going to, what I'm going to do, I'm going to swap a of low with a of j. Okay, this is actually the partitioning logic. In this way I'm going to do partition for all the other sub problem, sub part, right? That's why I followed the approach of recursion here. So let us take in one example here. How exactly I'm going to do this one? Just take here, take this example. Okay, element is there 54, 26, 93, 17, 77, 31, 44, 55, 20 is there. Okay, here left mark and right mark is there. Left mark is nothing but I. Okay, right mark is nothing but j. Okay, so first basically what I have taken here 54 as a pivot element. Okay, first I'm going to increment I, since the 26 actually in this part, in the left part, I mean after 54, I'm going to check the element which is actually greater than 54. But here in this right mark, I'm going to check the element which is actually less than 54. So if both the elements actually available for me, what I'm going to do, I'm going to extend that element. So just check 26 here. Since 26 actually less than 54, I'm going to increment I here. Okay, the same way here 20, since this one right mark here, since 93 actually uh, here 26 here, right mark is actually resides here only. So again I'm going to increment I, so I will check 93 as well as 20. Okay, so 20 is available here, check here. In this part 20 is already available. Since 20 is less than 54, no need to decrement j, because here the amount, the number which actually I am looking for, it's available 20, because 20 is less than 54, no need to decrement j. But here 26, here in this way I'm going to looking for a larger element. In this way larger element than 54. In this way I'm going to looking for smaller element than 54. So 20 is available, no need to decrement, it stays here only right mark. But here since 26 actually less than 54, I'm going to increment I here. Okay, so increment lie here, left mark actually left mark actually pointing to 93, and right mark actually residing 20 only. So just check here, 93 actually uh, greater than 54, so stop here. The same way 20, it's already available 20. Since the condition actually passes, I am going to exchange 93 with 20. Now right mark actually I mean see here 93 actually 93 and 20 has been exchanged here, 20 and 93. Right, again increment 17. Since 17 actually less than 54, again increment to 77. In this case 93 is over. In this way I'm going to looking for less element here, 93, decrement 93 to 54. Since 54 is actually greater than 50, 55 is actually greater than 54, again decrement j, so it's actually pointing to 44. So 77 available, 44 available, stick here 77, 44, just exchange 77 and 44, 77, 44 exchange here. Okay, see here in this case now check here 31, left mark is actually incremented to 31, where right mark resides in 77 here. Check here 77 actually greater than 54, that's why stop. Okay, stop the left mark. 31 is less than 54, stop. Since the right mark is actually less than left mark, since both are actually crossed, then exchange 54 with E of j. E of j in this case 31. Exchange 54 with 31. So one partition is over. Okay. So after this one, just check here. 31, I changed it 54 with 31. Just check here. Left part of numbers, left part of 54 pivot element is actually less than 54. Right part is actually greater than 54. So I found the correct position for 54. That's over. That is one partition. The same way I'm going to find all the pivot element for all the for the next subarray. This is left subarray and right subarray. So in this way, in all the iteration, after passing all the iteration, I'm going to find all the numbers right position, so that I will achieve the sorted arrays. Okay, this is actually the basic idea. Okay, so here left mark is nothing but I, right mark is nothing but j. The condition to exchange this uh, right mark with 54 is these two should be crossed. Check here, left mark crossed right mark here, right, and right mark crossed left mark here. So right mark left mark crossed, since both are crossed, I'm actually exchanging 54 with 31. Okay, this is actually logic of partition. So in this way I'm going to find all the partition for left subarray and right subarray, so that I can finally find the correct order for all the elements. So after all the iteration, the arrays contains sorted elements, ascending order sorted elements. Okay, so the logic is over now, right? So next I'm going to explain the testing approach, basis part testing approach. So why is this basis part testing needed? Since to execute the test cases, the program follows many approach. Okay, any program can be represented as a graph. Okay, so if you execute the test cases, there may be a number of paths exist. Okay, so for example, if a loop execute 18 times, it may contain 4.77 trillion paths. Of course, it's very impossible to find all the paths. It is very impossible to execute test cases for all the paths. So we need some minimum path, so that if we execute all the minimum path, that minimum path should cover all the complete program, so that we will going to cover execution of test cases for all the complete program within a small execution, small testing execution, and small amount of time. Okay, this is the basic idea. So the main idea is to find the cyclomatic complexity. Cyclomatic complexity gives you a number. That number represents number of independent paths in a program. If you execute the test cases for that number of independent path, then that is understood that you actually executed for complete program. You actually executed test cases for the complete program. You actually covered 100% of the program execution. Okay, this is the basic idea. So basis path, as I already said you, as I told you regarding this one, quick sort, just write the number from from declaration to end of the this one. Okay, closing bracket. So in some points you need to leave the numbering scheme here, like here opening bracket here, right? After 1 2 we missed the third, right? This opening bracket is not considered a statement. We follow to the next one, 3 4 5 6. Again the opening bracket is we are not considering as a statement, just followed in this way. the closing bracket is also not considered here. But the last closing bracket is very important since it actually tells you the exit program. Okay, only consider the last closing bracket. Okay, so after this one you need to write the diagram, the path diagram. So since the actual lab manual, there is no correct way of writing the program, since they have directly given this one, right? In the original program they have directly given this. There is no what is the meaning of ABC and all. That's why I have simplified this one with this graph. Just see here, one is the start of the program. So 2 3 4 5 is there. What is 1? In this case 1 is the first declaration part. Second, 2 3 4 5 is nothing but the loop, right? So after executing, since it is a loop, this loop follows two approach. One is whether it will follow true approach, or it will follow false. Either it will follow true path or false path. If it is follow, if the loop follows true path, it will directly execute. After executing the line 2, it will directly execute 3 4 5. That's why this 2 3 4 5 is considered as a sequence. Okay, this 2 3 4 5 is considered as a sequence, and this 2 3 4 5 is replaced with the node B. That is the logic of DD path. If there is any sequence of execution, just replace those sequence node with one node. That's why one is, there is you can't tell that 1 2 are sequence. Okay, the declaration part is different one. That's why one is only one node A, while 2 3 4 5 are actually sequence. This sequence is replaced by number P. So this P, after this one, either it will, if the condition is false, it will directly exit by following 20 node. 20 node is nothing but exit as the program. If it is true, it will directly go to 6, right? Here the 6, the line number 6 is also loop, while loop, right? So this while loop, as you people can see here, as you people can see here, while loop 6, right? If it is true, it will follow the right approach, right? While it will check whether while I is less than is equal to j. Okay, if it is true, it will follow directly go to 7. Okay, it will directly go to 7 node. What is 7 node here? 7 node is also while loop. Okay, while is key is greater than or equal to a of I. See here 7 and 8. Since it is a loop, check the loop of 7 and 7 8. If it is true, 7 8 actually it is repeated. That's why there is a connection between 7 to 8, 8 to 7. Since it is a loop, there is a connection between 7 to 8 and 8 to 7. Again, if it is false, directly go to node number 9. Again 9 is a loop again, right? 9 is again the loop while key is less than fj. That's why 9 10 is also loop. There is a edge between 9 to 10. Again there is a bracket between 10 to 9. Since it is a loop, there is a edge. If it is true, the loop will continue. If it is false, it directly exits from the loop. Go to 11. Just check 11 here. 11 will tell you if I is less than j. If it is I is less than j is true, 12 13 14 sequence will be executed, right? 12 13 14. This 12 13 14 is actually replaced by one node called which node? 12 13 14 I node. Okay, since it is a sequence is nothing but after one execution statement, another, after executing 12 13 should be executed. After executing 13 14 should be executed. If this is the case, it is called a sequence. This sequence can be replaced by one node. In this case, I replace the sequence with node 12, 13, 14. So, sorry, the node I. Other nodes like C, 6 is there is no sequence, that's why 6 is replaced with C, 7 is D with D, 8 with E, 9 with E, 9 with F, 10 with G, 11 with H. And again, after 15, it will directly go to 6. Why it directly go to 6? Because basically the node 6, I mean the this condition node 6 is nothing but while loop. That's why after completing that one, it will again go to while loop only 6, right? That's why there is a connection between 14 to 16, because it is a while loop. If it is true, it will directly go to this while loop. Okay, so for example, if it is false, this condition while is I is less than is equal to j is false, what will happen? It will directly go to the line number 15. That's why there is a connection between 16 to 15. So 15, 16, 17, 18 will be executed. 15, 16, 17 will be executed. Okay, 15, 16, 17. Again, this 15, 16, 17 is replaced with one node called j. Since it is a sequence, it is replaced with number j. You can check here, j, right? 15, 16, 17 is replaced with j, and I is replaced with the node 11, 12, 13, 12, 13, 14, right? This is actually the replaced version. Okay, so after that one, just check 8. 8 is actually recursive call, that's why there is a connection between 18 to the node b. Again, 19 also the recursive call, that's why there is a connection between 19 to the node b. Okay, quicksort a of low j minus 1 and quicksort a j plus 1 I. That's why there is a connection between again it will go directly go to the if condition only. From the statement 1 only it will go to execute. Okay, that's why this is actually the version. Okay, so you can I can simplify by replacing with this one. These are a DD path, these are actually program graph node. This is simplified DD path node, same as the previous one. So if you check one by checking this condition, so edges is equal to 18, just because just check the edges number. There are 18 edges are there. Nodes are, how many nodes are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 nodes are there. Okay, according to the cyclomatrix complexity formula, v of g is equal to e minus n plus 2p. Why is 2p? There is no connection between the last node m is actually last node m to a. Okay, that's why it is 2p. Okay, it is actually 2p. Here's the program here. So according to this equation, 30 18 minus 13 plus 2 is nothing but 7. There is actually 7 independent paths are there. If you execute 7 test cases, you are actually covering all the aspect of complete program. That's why this is you're going to follow this approach. First line is first path is P1 is ABM. ABM is the first path. Next path is ABC JKB. ABC JKB. That is second path. Third path is ABC JKLB. ABC JKLB. The same way we have 7 paths are there. So we are going to execute test cases for this 7 path. This will cover all the aspects of the program by giving only one element, 2 element, 3 element, give in ascending order, give in descending order, give pivot element as a minimum, give pivot element as a maximum. In this way, you will actually covers all the aspect of test case execution. Okay, this is the way you can execute the program. You can give number. Okay, for example, ABN, right? ABN in the sense you can give number of one single number like this one. Okay, because there is no two numbers are there, it will give like sorted number, only one element is there. ABJKB. What is ABCJKB? ABCJKB ABC JKB is nothing but which one? This one. 1 2 3 4 5 6 15 16 17 18, again 4. In this case it won't execute this path. In the sense this condition is false, while I is less than is equal to j is false. That's why it's directly go to this one condition. That's why here we have given this one. For this approach we are giving 5 4. Okay, since we are giving 5 4, okay, what will happen? It will check whether 5 is less than 4, right? While 5 is less than 4, that's why there is that the condition is false. That's why it will give this one. Repeat and static elements will be given. Okay, in this way we execute completely 7 test cases. Okay, this is actually the program 11. Okay, okay. So in the next video I'm going to do is the last program, that is 17. 17 is very easy. Okay, I'm going to do a video for program 17. Okay, thank you.